Produced by PI Media.
Hi, listeners, and welcome to the Wix Engineering Podcast. I'm Ran Levy. Have you ever tried to build IKEA furniture? It's a nightmare. You get all the component parts that make up a couch or a chair, instructions, and the rest is up to you. At first it seems fun, but inevitably you screw up, or there's some little piece you can't find anywhere, and without it, the whole thing falls apart. So that's my review. When it comes to furniture, give me the whole thing. Sometimes, though, I like assembling things. I like playing with Legos with my kids, for example. I build my own PCs. Even though I don't have to, it allows me to come up with something that's probably better than what they give you off the shelf, and I feel a sense of control in knowing every nook and cranny of my machine. Programming is about building things, but there are very different ways to do it. Most developers work on large code repositories, files with thousands upon thousands of lines of code which reference, call, and stack on top of one another to create a crazy complex final product. Most developers are diligent, detail-oriented, and very intelligent, which is how they manage to wrangle these giant beasts of theirs. But you can also build software more like a Lego set. Instead of one big complicated thing, you break a codebase into small component parts that can be addressed individually, rearranged, and swapped in and out as you'd like. That's what our play is about today, the Lego's way of designing software. Let's meet our players.
So my name is Or Ben-Ari. I'm a front-end developer at the Wix Blocks team, and I've been at Wix for the past 4 years now.
I'm Inbal. I've been at Wix for 4 years, and 3 years out of them is in the Blocks team.
The Blocks team that Or and Inbal are part of is responsible for a particular service that integrates with the Wix website editor.
Wix Blocks is a visual design workspace to build apps and widgets that can extend the functionality of the Wix editors and the sites that are built using them.
Basically, customers use the Wix editor to build their websites and Wix Blocks to create new functionalities for themselves that may not otherwise be available in the editor itself. Because it's an extension of the editor, they base the code for Blocks off of the original code repository of the editor.
These widgets are composed out of the same elements that compose the sites, such as buttons, images, and texts. And so it is natural to base this workspace on the editor itself.
So at first we started our project inside the existing repo, and we used the state management, the Redux state management in the editor in order to override existing features. So if, for example, we wanted to hide a certain button or something, we would just set the state to hide and set all kinds of overrides, and then we got our workspace instead of the editors.
It seemed logical enough. It didn't quite work out, though.
So the root of all of our problems was the fact that our code was implemented inside of the editor's repo. This includes a few problems. First, the two projects' builds are coupled. Every little change that we needed to introduce into our product would involve building the entire editor project, and vice versa. And the editor, being a complicated project, means that its build is long and it is sometimes unstable. So if every time we needed to introduce a new feature, we are blocked because of the editor's build, this is bad. Additionally, this architecture affects the loading performance of the Blocks app because we are loading a lot of unnecessary editor code.
The code became really tangled and unclear, and we had to add some logic to load our block's logic inside the editor when it's not needed, and we got the editor's logic when we didn't need it.
And it also affects the editor's performance because the editor loads a lot of blocks code.
The Wix editor was a big, complicated beast that resisted change. Not because it was bad software, but because it was designed for a specific purpose and that purpose alone. And because software in general is quite complicated. It's tough to pick and choose what you like and don't like amid a web of tens of thousands of functions which reference and build off one another in different and not always obvious ways. The result was a project that was more difficult than it needed to be, and a product that was less optimal than it could have been. Not responsive enough, not customizable enough.
The first Wix blocks produced widgets with absolute component positioning, which is problematic when you want to create reusable widgets that can have varying layouts and sizes.
So we wanted to create responsive widgets, fluid widgets.
The architecture of the editor at the time didn't fully support this approach.
But all that soon changed when the Wix editor team decided to redesign their software.
Built using a library called Repluggable. It's a library written by Wix, which is now open source. And this library implements modular front-end applications using inversion of control.
Modular. That's the key word here.
So firstly, before we get into it, just one of you tell me what modular software is.
Modular software design emphasizes separating the functionality of a program into independent interchangeable modules. Each one of these modules is responsible for one aspect or several features of the application. And these modules can be loaded or unloaded into our app. These modules should be independent and interchangeable between them.
Modular is the custom PC, the Lego way of doing things.
When you have the Lego blocks, you can separate them and just take the one you want and throw away the ones you don't want. So you just use the only thing that is beneficial for you.
Using the old Wix editor, removing any given feature or changing anything significant was difficult because everything was tangled together. The new editor, called Editor X, was broken up into modules, Legos that could easily be swapped in and out.
It was clear that this modular approach of Editor X provided exactly what we were looking for.
So Or, Inbal and their team decided to scrap their old blocks built off the old editor in favor of a new blocks built off the new editor, using the principles of modular design. Foremost among them,
a design concept called inversion of control, or IOC for short.
Inversion of control does what it sounds like it does. It takes the usual order of what code controls what depends on what, and reverses it. For example, let's imagine a toolbar running across the top of a web page and a button on it, maybe a home or a menu button.
In a naive implementation, what would happen is the top bar module will import the button module and simply render it.
Now, what if you want to keep the bar but remove the button? The button code, as you might guess, derives from the toolbar code.
If we want in blocks not to render this button, we need to change the top bar module's code.
It gets the job done, but it's a bit clumsy. We have to import the button code we don't actually want, only to do the work necessary to make it go away, or at least appear to go away.
In an inversion of control design, what we do is that the button module imports the top bar module and somehow contributes this button to the top bar, and then the top bar renders it.
In other words, instead of the button being part of the toolbar code, the button is its own module. Thus, we can treat them as independent units. We may or may not want them to interact with one another, but neither will be dependent on the other.
And what this means is whenever a new module wants to add content to the top bar, there is no need to change any of the top bar's code. And if we want in blocks to hide this button, all we need to do is not to load the buttons module.
By building with modular software using inversion of control, the new Wix blocks could simply pick and choose the features of the Wix editor they wanted and recombine those features with whatever new features they wanted to build with it, like interchangeable Lego blocks. Still, it wasn't all so simple as building with Legos. Even with a modular approach, it was difficult to draw very clear borders between different parts of a codebase.
It raises the question that, software, at least I've always assumed, I think a lot of people assume, that it's very sort of complex, interconnected, interdependent, everything sort of works together. So how do you guys even begin to break up a program into independent and self-sufficient component parts?
My initial answer would be that it's difficult. It's an iterative process that you don't just do in one go. Sometimes it feels more like an art than a science. And a lot of the times you need to revisit modules you wrote and refactor them and break them apart. But as you do it more and more, you start to develop good intuitions as to how to do it.
I think we just know our code very well. So it was, it's the second time we write this project. So we just take it, and we didn't always know what to do and where to put it. But you can always start with a big module, and then you see, oh, this feature also requires this one, and it's not really related to this, so let's create a new module.
Sometimes the difficulty in drawing clear border lines between modules led to some unforeseen consequences. For example, as they started loading modules from editor X into the new Wix blocks, they picked only those they wanted and ignored the rest, obviously.
So our initial solution was to use what we called an allowed list. This is a named list of all the modules that we want to share between editor X and blocks and to load into the blocks application. And this approach proved a bit problematic because, for example, if there is a module, let's call it module A, and it was not in our list, we don't want its functionality, and a module B, which is on our list, suddenly in a new version added a dependency on module A.
Modules A and B might have been treated as separate units, but in reality, B was still dependent on A.
This would break us. This would break the blocks app.
They mulled over how to fix the problem.
Now, of course, we could create some elaborate mechanism that will load module B and its entire dependency graph, so module A will be loaded also. But this was challenging because of several engineering difficulties. So what we ended up doing is switch to a not allowed list, a list of all the modules that we don't want to load from editor X. And so we load everything except for what's in this not allowed list.
So I can see the benefit of, instead of only allowing what you want, only unallowing what you don't want. That makes sense. But wouldn't this not allowed approach make the code base necessarily larger? Wouldn't you end up dragging in features that you don't actually need in the end?
Because we share modules between two projects, we are always at the risk of inheriting functionality or changes that we don't want to get inside of Wix blocks. This is a problem which is inherent to this architecture.
To avoid ending up with lots of unnecessary code, the team used end-to-end testing. It helped them see what they had on their hands and figure out what was unnecessary and removable.
Visual tests and logic tests, and we keep track of stuff. It can happen, but our test prevents most of it. And we do share a lot of the logic with Editorix, so we do want most of the features. So it's still the preferred way for us.
What were the benefits of the modular approach for the project?
It enables us to reuse a lot of functionality from the Editorix project, but customize it for the needs of Wix blocks without writing a lot of code inside of Editorix's repo. So the code base is easier to maintain, and both of the project's builds are faster and more stable. It also allows for faster loading times, as blocks doesn't load unnecessary Editorix features and vice versa.
I don't know, I think we just had a lot of pain points in the past, working in one huge repo, long builds, a lot of bugs, a lot of time to get in production. And now it's much more fun, and we can create many features.
And what, if any, were the downsides of the modular approach?
So it's more complicated, and there's more boilerplate, and it's less natural, the inversion of control or talked about. Like when you write something, it's more natural to just write it and write the children, and there's the native structure. And here you need to change a bit the way you think about stuff.
Modular programming with inversion of control is just less intuitive for programmers who are used to organizing their ideas in a certain way. It takes some getting used to.
There's the learning curve you talked about too. How are we going to even decide which models we need? So that's the downside.
Ultimately, modular programming is suited to some kinds of projects and not others.
So I wouldn't recommend it for small or medium scale projects, because as we said, it's complicated and there's no need if you have a small project. But if your project starts to get larger, or your basic assumptions change and your code becomes tangled and spaghetti code, then I would think about modular approach.
For larger projects, when you're stuck with a giant code repository and all kinds of intertwined dependencies, modular programming can make all the difference. It can save you from all the long hours and future headaches you'd otherwise have to endure in trying to untangle code and reverse engineer errors that seem to pop up out of nowhere because you missed something. But maybe the best part about modular software is that, like Legos, it can be broken down and customized into entirely new things.
When the Editorix team developed Editorix, they could not imagine that another team would be able to take these modules and transform them in such a way that will produce something like blocks. And this is an amazing thing, that you can build something, and future developers can transform it in ways that they could not have imagined.
That's it for this episode. Thank you for listening. The Wix Engineering Podcast is produced by PI Media, written by Nate Nilsson, produced by Yotam Halachmi, and narrated by me, Ran Levy. Special thanks to Morad Stern from Wix. See you again next episode. Bye-bye.